Okay, welcome back to the video lecture series for Intro to GIS at Radford University. For those of you who don't know me, I'm Andrew Foy, an instructor here, and what I want to talk about today is kind of just some conceptual basics for doing overlay analyses in the GIS. And so if you think back to one of the really powerful things that a GIS does is it allows us to take different layers or different pieces of geographic information and overlay them together to create maps that would be much more difficult if we were dealing with just paper maps. So this discussion is really going to focus around how we can use different layers or different features to identify places that are basically the most suitable for a lot of different types of applications. And so overlay analysis is done for a variety of different reasons. One kind of classic example is Walmart's, and they have a very good spatial model that looks at maybe distance from a highway, proximity to neighborhoods, different demographic and economic factors, and they look at all of these spatial variables and try to find out areas where all of the important factors occur together. And that place would be referred to as being maybe the most suitable location or the best location to put a new Walmart. Now, these sorts of applications extend far beyond business kind of examples. So there are a lot of biological examples. For example, we might want to talk about the best place to grow a certain crop or a certain variety of wine. Or maybe maybe you're a brewer and you want to know what type of hops to grow in your region. Well, you could look at all the different environmental factors and determine the most suitable place to grow a certain type of crop. Or there are even other examples. So right now we're working on the Wind Colorado lab where we want to find the best place to put a wind farm. Or if we go back to the geospatial revolution, they tried to determine the best place to put a new grocery store in Philadelphia. So there are tons of different applications, and what overlay analysis kind of forces us to do is to think about what factors are important for certain types of geographic phenomena. So now that we understand basically the idea of what overlaying is, again, overlaying is putting different layers together on top of each other. Let's talk about the different types of overlay tools that we may use when we're doing an overlay analysis. Okay, so I don't really care what GIS package you use, whether it's QGIS or GeoMedia or ArcGIS. The basic overlay tools exist in all of these packages. In ArcGIS, they happen to be compartmentalized in the overlay toolbox, but these tools exist, like I said, in any other GIS. So what you're going to learn here conceptually is the same across all platforms. So that there are three basic types of overlay operations. We have intersections, we have erase, and we have unions. Okay, the three main ones. The one that we're going to focus on using the most is intersects and erases, but there's also something called a union. And we'll talk a little bit about those in greater detail. But to go back to what we're trying to accomplish in the overlay analysis, we're basically using tools that intersect layers, that erase spots or locations from other layers, or combine other layers together. And we're doing all of this to typically identify places that are most suitable for something. So here we can see that we have a layer that is soil, different soil types. We have a layer that relates to the amount of precipitation in a region, and we also have a layer that tells us information about the temperature. So go back to one of our examples where we want to grow certain varieties of grapes. Maybe they have certain soil requirements, certain precipitation requirements, and certain temperature requirements. If we can extract those out as factors and then create layers that say, hey, these are all the spots that have good soil, that have the correct amount of water, and also the correct temperature, we can overlay those together, which will result in a layer that tells us the spots where all of these conditions were met. Okay? So the way this happens using these tools is a little bit different. The first tool, or the first operation that we want to talk about, is intersections. And we can go back to basically Venn diagrams to see what happens with an intersection, right? We have one layer that might be soil, and another layer that might be water. When we run the intersect tool, it overlays the soil with the water, and it looks for places where those two layers intersect. So with this diagram, this area would be where both the soil and the water parameters intersect. So the layer that the result from the intersect operation is just this. The place where both conditions or good things happen. The nice thing about running intersect operations is that you can do it with many different layers. So if there were 10 factors that were important for whatever you're trying to model, you could intersect all 10 layers at one time. The next overlay operation I want to talk about is an erase operation. And so imagine that again, we have a polygon. This may be something like a national park or a grassland or something like that. And maybe we're looking for a spot to conserve a certain type of species. But within this national park system, maybe there is some sort of refuge that's off limits that we're not allowed to use or to access. So we have another layer that represents spots that we're not allowed to get. And so what the erase operation does is it takes a base or an input layer, input feature, and it also takes an erase feature. And when we overlay them together, what happens is that the erased area, or what our erase input is removed from the input feature. So it would look something, our new polygon would look something like this. I'm not the best drawer, but I think you get the idea. Yeah, that would be right. So the polygon as it looks now would be everywhere that is filled in black. And so we've effectively removed or used a cookie cutter to suck out the area that's no good. So erase operations remove stuff from the input layer. They erase it. It's like a cookie cutter. They cut it out. Whereas intersects look for where both things occur and everything else goes away. So they kind of do the opposite of each other, but oftentimes we use them together when we're doing an overlay analysis. Now the last one I want to talk about is union, which is a little bit simpler, but still important. So imagine we have two layers and they don't overlap, they don't intersect, and we don't want to erase anything from it, but we want everything to be in the same feature class, right? Or in the same layer or in the same shapefile. So if we have a square and again a circle, and these things exist in the same space, so right, one layer, two layer, we're just looking at it a little differently. And we run the union tool, but what happened is we would preserve the information of both features. They would just live in the same space. So we would have the circle as a feature class over top of the polygon as a feature class. We haven't erased anything. We haven't intersected anything. We just put them together, made a union, right? And so sometimes this may be useful if you're trying to combine information from multiple data sets. So remember, at the end of the day, overlay operations aren't anything new to you guys because we've been overlaying data for a long time, but now we're talking about how to change layers based on overlays, how to look for places of overlap, how to erase or remove areas that are not suitable for certain things. So lots of different applications. And again, what we're working on right now is trying to find the best place to put a wind farm. So we're saying, hey, where is there enough wind to support the wind farm? What areas are close enough to a road where we can easily access it? What areas are nearby urban populations that need power, right? And so we can kind of use all of these different lines of evidence to make an informed decision about the best place, again, or the most suitable place to put a wind farm. And just to review, the 3 overlay operations most commonly used when we do simple overlay analysis are things like intersect, erase, and union. As we progress in the semester, we're going to get more and more complex, and we're going to talk about how to weight different types of layers so that variables or factors can contribute differently to a model. So for example, temperature might be more important than water. And so if we're doing an overlay analysis to figure out where we need to put a certain type of grape, we want to allow trade-off, and we want to know or represent that one factor is more important than another. So we can do weighted overlays or even more complicated fuzzy overlays. But these are topics we'll get into discussion a little bit later. And I also want to make the point or clarify that what we've talked about today is vector overlays, not raster overlays. And again, we use 2 different models to represent objects and geographic objects. We have vector-based data, which is points, lines, and polygons, and we have rasters, which are basically pictures of the Earth, or grids with a bunch of cells in them. So we can do vector-based overlay. We can also do raster-based overlays, or a combination of both. And so in my next video, what I'm going to talk about is raster overlays. Okay, so that's basically the end of my demonstration. And what I want you guys to do to complete the work or your work for the rest of the week is to write a short half-page to a page Word document reviewing the 3 different overlay operations and kind of the basic concept of why we might do an overlay analysis. So talk to me about how we use different layers to do overlays and then identify places that are the most suitable for different geographic phenomena. That's all. And put it in the Dropbox in D2L.